Find an upper triangular U not diagonal with U squared equal 1, which gives U equal U inverse. Okay, so I have to find U. So let's see. First, it's an upper triangular matrix. What does this mean? This means that if I have under the elements of the diagonal, which I don't know what they are, by the way, to the left of these A, B, C, three unknowns, I have zeros. That's what an upper triangular matrix mean. And above there, I don't know what they are. So let's fill in. So A, B, C, D, E, F. So this is our U. This is our U matrix. Okay, now we have 6 unknowns, A, B, C, D, E, F. We have to solve for these. So now I notice that one of the requirements is that U equal U inverse. So what I could do is I could find the inverse for U. I could set it equal to U and set them equal and solve for these 6 unknowns. So now in the way I'm going to do U inverse, I'm going to do it using row manipulation from the identity matrix. So I will line up the identity matrix right next to it. So this is the identity matrix, and we're going to manipulate the rows so that the green matrix, the U matrix on the left, turns into the identity matrix, the red one, and whatever the red matrix turns into, the identity matrix, that would be the inverse of U. And then we go back and we set it equal to U. So let's get started. So the first step is I need this guy to be a 1, not an A, because you start on the first column and you go down the column to make it identical to the first column in the identity matrix. So this needs to be a 1. So that means I need to take row number 1 and divide it by A, or multiply it by 1 over A. I could do that. So then what that will do, that will turn that into a 1. This becomes D over A. This becomes E over A, 1 over A, 0, 0. On the rest, nothing changes, of course. So 0, BF, 0, 1, 0. Okay, let's put a divider here. Okay, so the next step is to go down the first column and make this guy a 0. It's already a 0, so we're good to go there. The third one is 0, already 0, good to go there. So we're done with the first column. Now we move on to the second column. The second column, this guy here needs to be a 0. It isn't. So we need to make it a 0. So let's see. Let's use black. Okay, if this guy needs to be a 0, obviously I need to multiply my second row so that I don't change the first element in the first column, because if I multiply row number 2, whatever I multiply row number 2 by, 0 doesn't change, and when I add it to 1, it doesn't change the first cell on the first column. So I need to multiply row number 2, so and then so I need row number 2 to be added to row number 1, and this guy needs to go away. Now first of all, there's no D over A here, so I could multiply row number 2 by D over A, and oops, I should put this next to row number 1. Actually it's fine. Yeah, because this is the row that needs to be changed. Okay, so row number 2, multiply it by D over A. So what does that makes it? That makes it BD over A. Well, I need the B to go away, so I could divide by the B. So now if I multiply B by that, I get D over A, but if I add it, I need it to go away, so that means I could do a minus sign here, and I could add it to row number 1, and that guarantees this element here to go to 0. So and then of course we have to apply this on all of them, so let's go ahead and do that. The 0 here doesn't change, so 1. This guy becomes a 0, and this is going to become minus FD over AB plus E over A. Oops, wait, AB, yeah, E over A. That's wondering if I got the E confused with a C. I didn't. Okay, 0, nothing changes here. 1 over A, 0, 0, and then everything else stays the same. So 0 BF 0 1 0 0 0 C. Oh wait, this one here changes, yeah. Row number 2, this gets multiplied minus dA over B. When I add it here, I get minus D over AB because you're adding it to 0. Okay, good. So move the splitter now that we need more space. Okay, now we need to go down this guy. This B needs to be a 1. Let's use gold. This B needs to be a 1. So I could go row number 2 divided by B to make that a 1. So then I would get 1. Let me start here. 0 minus FD over AB. If I take a common denominator AB, this becomes plus EB. And then we have 1 over A minus D over AB 0. And here we're going to divide by B, so 0 1 F over B 0 1 over B 0, and then we have 0 0 C 0 skip by 1 cell. Okay, here we go. This fixes. Okay, 0 0 C 0 0 1. Okay, the divider is here, and this is where I am so far. Okay, going down the second column, the third one needs to be a 0. It already is a 0, so I'm good here. Now this guy here needs to be a 1. Sorry, this needs to be a 0. Okay, this is gonna take some thinking now, not much, but some. So this needs to be a 1. Okay, so what we could do, the C is here. Okay, it's simple. I don't want to change anything above, so I have to operate on row number 3 because it has the zeros. So if I do that, let me just put it here. Okay, so what I'm gonna do, I'm gonna multiply row 3 by exactly that over C. So if I multiply row 3, where should we write this step? I'm running out of space here. Let me try to zoom. Okay, it's fine. I'll do it here. So I'm gonna multiply row number 3. Let me do it in a different color so we distinguish it from the. Actually, I'm gonna bring those closer so I can have the step right next to it. 1 second. Sorry about that. I'm gonna move this in a bit. Okay, so I can write the step here. Okay, so this needs to be a 1. So I'm gonna multiply row number 3 by the same thing except positive. So FD plus EB over AB. However, there's a C here which gonna multiply there. So that means I also have to divide by C. So when I multiply by C, this goes away, and then when I add it to row 1, so plus row 1, I get a 0 up there. Okay, so let's do that. Now notice those here are zeros, so nothing will change. So it doesn't mess up my 1 0 here that I already fixed. So I'm gonna get 1 0. We already said this is 0 because when we multiply it by C, the C goes away, and then they're the same except opposite signs, so they go away. If I multiply here, oh, this is nice too. See, there's zeros here, so this doesn't change. And when I add it to 1 over A, I just get 1 over A. And then the same thing here, so minus D. So it's not as complicated as it seemed to be. Obviously, an upper triangular matrix, most of the elements are 0 or half of them, a little less than half. That makes things a bit easier. Okay, that's it. So now I rewrite. So let's see here, row number 3, oh, this is not a 0 of course because I multiplied row number 3 by that, so this is going to become FD plus EB over ABC, and then add it to 0, you get the same thing. Okay, the rest stay the same. I only changed the first row. 0 1 over B 0 0 0 C 0 0 1. Okay, good. We're close. Now this is the divider, so 0. Now this guy needs to be a 0 right here. Now, let's change the color. This guy needs to be a 0, so I have to operate on the third row. So if I multiply the third row by f over, I ran into the same problem again. Let me bring those a bit closer so I can have room for too close. Okay, good. So now if I multiply row number 3 by negative f over b, but there's a c there that needs to go away, so I would put a c here, and I would add it to row number 3. So add it to row number 2, so that that would make it a 0, yes, because we would get minus f over b, because the c cancels out, plus f over b, I would get a 0, so I'm changing this row here. So first row stays the same, 1 0 0, 1 over a minus d over ab, and then we have fd plus eb over abc. Okay, so these aren't going to change because they're zeros, so I will get 0 1 here. This, as I promised, will be a 1 because you will get minus f over b plus f over this will be a 0, plus f over b minus f over b. This will get us a 0. Now this is a 0, so, and this is a 0, so nothing will change here. We will get 0 1 over b. Okay, here this will change, so if I multiply the 1 by minus f over bc and add it to 0, I'm going to get minus f over bc, and the third column remains the same. The third row, 0 0 0 1. Okay, nice. This is the divider here. I keep moving the divider, I apologize. I just want to make sure I have enough room on the right hand side so I can write down my operation that I'm planning to execute. Okay, good. So now the last step is to make this guy a 1, and that's very simple. That's just row 3 times 1 over c. Okay, good. So this would be the last step, and we will get the inverse here, which is the first step towards solving this question. So 1 0 0, 1 over a minus d over ab, fd plus eb over abc. Okay, 0 1 0, 0 1 over b. Nothing changes on the second row. Oops, this is an f, b, c, and here I'm going to divide by c. 0 1 0, bingo. 0 0 1. This guy now became the identity matrix, and we will get 0 0 1 over c, and so we can see that our inverse is this guy sitting here on the side. This will be, of course, our inverse. This is U inverse. Let me pause this for a moment. I gotta use the restroom. Okay, just noticed here that I had, now that I was looking back through this, I noticed that there's a minus sign here, mistake that I forgot to put when I multiplied row 3. This should have been a minus here. I forgot this minus sign here. It's maybe not big enough that I forgot it. Okay, plus row number 1, so this will change things. So this will still be a 0, but then when I multiply this, I will get here a minus. Okay, fair enough. which means there's a minus here that will carry over. Second. No, wait, it's supposed to be the reverse of this. So this is supposed to be minus EB here, so that it switches, so that so when I add it I would get 0. Okay, so this minus sign, luckily here we didn't use this, so this is going to be a minus, and this here is a minus sign. Okay, good. Which one here we didn't do anything with this, so there's a minus here. Okay, good. So yeah, okay, good. FD minus EB. Okay, so now this is the inverse of my matrix. Let's see. Okay, so now I will equate this with U. I will equate this with U. So U was 0, A, B, C, 0, 0, 0, and we had, what order did we have this in? D, E, F. Okay, D, E, F. Okay, good. And these two have to be the same, which means their corresponding cells have to be the same. Now clearly the zeros are the same, otherwise we have done something wrong. So now by just looking at this guy needs to be the same as this guy. So A has to equal 1 over A, or A squared has to equal 1. Well, one of the values is 1. Let's stick with 1 and see what happens. So A is 1. Now let's see, also B has to equal 1 over B. So B has to equal 1 over B, which means B squared has to equal 1, which means B, well, B could actually, let's consider plus or minus and see what happens. B equal plus or minus 1. Okay, and what else? We have plenty more. We know that C has to equal 1 over C. So C has to equal 1 over C, which makes C squared equals 1. Okay, and now plus or minus 1. Yeah, 1 for it. So C equal plus minus 1, right? Okay, now we know also that D, let's change colors, has to equal minus D over AB. So D has to equal minus D over AB, right? Now here's the thing. Notice that these guys have to be opposite sign for this to work, because if A is minus 1 and B is minus 1, this will make the product a 1, and therefore D cannot equal minus D. So this tells me that for an arbitrary choice I need to pick opposite signs on A and B. So if I pick A to be 1, B has to be minus 1. So that would make this side equal to that side. Okay, good. So that kind of confirmed the choice here. And of course, if that's the case, then I wouldn't get anything from here. I'll just get D equal D. So let's move on to a different cell. A different cell now. We are this guy needs to equal this guy, no? So F has to equal minus F over BC. Okay, good. Again, I already picked the B to be minus 1, right? Now that means that makes C a 1, because otherwise these two sides would not be equal. So I need to choose C to be a 1, not a minus 1, for this to work, so that the minus sign is cancelled and I get F equals F. Okay, so far I found A, B, C. Let's move on to the last cell, which is this cell here. Let's take this color. So this has to equal E. So FD DF over DF minus EB over ABC has to equal E. Okay, let's plug in what we know. So what we know is DF B is minus 1, so this is plus E over ABC, that's just minus 1, equal E. Oops, 1 second here. So yeah, okay, good. So no, not really. So DF B is minus 1, which makes this plus, and ABC. Okay, so now if I cross multiply, I would get DF equal minus E minus E. So I would get DF equal minus 2E. Okay, notice I don't have other equations to solve here. I ran out of equations, which means what? Notice that if this E had cancelled out, I would have been able to get an answer. How would I do that? Well, what if I flip the signs here? Remember here how I chose the AB, one to be a 1 and one to be a minus 1? Now, what happens if I flip that? What happens if I choose this to be a minus 1, and because I'm unable to solve for the rest of the unknowns with what I chose. So now I'm going to change the choices. So I'm going to make this a minus 1 and this is a 1, which would still satisfy this, because then we would get D equal D. Okay, and I'm going to make so now that B is plus 1, this means C has to be negative 1. So now I have minus minus plus. Okay, good. So this equation is also still satisfied. Okay, and now when I get here, I will get, well, B is 1. So now this is going to become, let's see if this is going to fix it. This is going to become a minus E, and ABC will be a plus 1. A, B, C. One second. B. Okay, that's still not gonna do it, because you see, that's still not gonna do it, and the reason being is because I'm still gonna get more unknowns here. This is gonna become plus 2E. Okay, so that's the second choice not gonna work. Let me go to the third choice. What if I pick A to be minus 1 and B to be minus 1? This is the only option I'm left with. So we're gonna make this minus 1. Okay, now I agree. When you stick this here, then you get D equals minus D over AB, right? Which is 1. AB is 1. So you get D equal minus D, right? So this doesn't make sense, except if D is 0. So this choice gets me D equals 0. So let's see if this is gonna work. Now, here, let me switch this to a plus 1 instead of a minus 1. Okay, and now let me let me erase this junk here. So it's getting a little messy, I apologize. So if we plug these in, we will get f equal minus f bc over minus 1. Okay, so f equal f. Okay, fair enough. F equals f. There's nothing wrong with that. Okay, now let's go to the third equation, which says E equal FD, which is the one that didn't work out, the one that stimulated me to do these changes, triggered me to switch the signs. FD minus EB over ABC. Okay, let's see what that gets us. So E equal FD, D is 0, so this goes away, minus EB. E is we don't know, undetermined, and B is minus 1, so this becomes plus E over ABC. ABC will be 1. Okay, again, I'm stuck with two equations. E equal E and F equal F. Well, guess what? This has an infinite amount of solutions, yeah? So why not choose F equals 0, for example? And if F equals 0, what will E? So I could assign one value for F. And yeah, D is 0, so that went away. So I still need to find E. Okay, so then I would get U inverse, or U equal. Now remember, I still haven't used my my second constraint, which is U squared equals I, and from that I can find my E. Okay, so then this will become A was minus 1, we chose, yeah, minus 1, so U equal minus 1, 0 for B, right, for D, yeah, 0 for D, and E is E, and here we got 0, minus 1, 0, right, A, B is minus 1, and these were zeros here, it's an upper triangular, and then the last one, ABC, C, we choose C to be 1. Okay, good. So this is my U. So far unfinished business, because I still don't have my U, my E, so this guy is still an unknown here. Okay, so let's go ahead and find that. So U squared, I would have to multiply these with each other, so minus 1, 0, E, 0, minus 1, 0, 0, 0, 1, times itself. Okay, so assuming people here in this class are fairly comfortable with matrix multiplication, but I'll just go ahead and illustrate one of them. So the way matrix multiplication goes is I multiply row times column, corresponding cells with each other, and then I add them. So minus 1 times minus 1 is 1, plus that drives me crazy. Minus 1 times minus 1 is 1, plus 0 times 0, 0, so 1 plus 0, and then E times 0 is 0, so the addition gets me a 1. And then I move on, first row, second column, and I do the same thing. So 0, 0, 0, so this is a 0. And then first row, third column, minus E plus 0, minus E plus 0 plus E, so that's a 0. And then second row, first column, so 0, 0, 0, so this is a 0. 0, oops, 1, 0, 1, and and then third 0 0 0 0 0 0, and then 0 0 0 0 0 0 0 0 1. Great. What is it? The identity matrix, right? So this is equal to the identity matrix. So I didn't really need I mean, it doesn't really matter what E is. E could be anything, and I would still satisfy. Notice here I got an equation E equals E, so whatever I plug for E, it will work out. There's some freedom here, and regardless of what E is, when I multiply the matrices, I would still get an identity matrix. So my both constraints are satisfied with an arbitrary choice on E, which you could have made that choice on F, by the way. So yeah, so E could be anything, and with that said, we had found an upper triangular matrix, and this upper triangular matrix will be with this and E to be chosen. So U will equal so this is our final answer here, minus 1 0 E 0 minus 1 0 0 0 1. That does it. E, any real number. You can either you can even choose U to be E to be 17.7 if you like. That concludes this interesting problem.